This demonstration highlights the unique benefits of iGrafx process for Six Sigma. I'll show how to use process for Six Sigma to rapidly design and test experiments, called rapid DOE, and the ability to fit external data to common distribution functions for use in process simulations. These features and the process analyzer are unique to process for Six Sigma and not found in iGrafx Flowcharter or iGrafx Process. Before watching this demo, I recommend viewing the iGrafx simulation demonstration first. In this demo, I'll act as manager of a new e-commerce operation where I've decided to use my Six Sigma black belt skills to analyze my team's resource utilization. I'll use iGrafx Process for Six Sigma and Minitab to optimize staffing levels and resource costs to increase process throughput. iGrafx Process for Six Sigma is also tightly integrated with SAS Jump. My customers have signed up for a financial newsletter service that targets special interest groups. Members identify their interests when completing their sign-up form. The newsletter service is currently producing 54 newsletters a month at an average cost of over $550 per newsletter. The company business plan and empirical data suggest I'll need to distribute at least 70 newsletters each month next quarter, a 30% increase. I suspect that I'll have to hire additional resources to reach that goal. The question is, in which department or departments should I increase staffing levels to meet the production goal while minimizing costs? I'll begin with a process map created earlier by one of our greenbelts and stored in the company Process Central repository. To modify and analyze, I need to check out the newsletter process. There are two parallel flows in the process, creating the newsletter content, shown with the blue shapes, and creating the newsletter distribution list, shown in the green shapes. In the blue activities, managers, writers, and graphics groups are tasked with creating the content. In the green activities, the production team extracts the appropriate member names from the database of 300,000 members. A product content manager initiates the process. The opportunity for a newsletter is identified and given to a writer to carry through to completion. At activity number 6, the writer outlines the text and the pertinent URLs. In the Properties dialog, my greenbelt entered the average estimated time to perform this activity, 15 minutes. I, however, want to enter a more accurate figure based on actual timings for this activity. I have 30 timings of this activity stored in a Minitab spreadsheet. Using the Six Sigma fit data command, I'll fit this data to some common distribution curves. Judging from the Anderson-Darling measures and the plotted normal function, I'm confident that it is the accurate function for my raw data. I click Copy. In the Properties dialog, for this step, I change the duration time from a constant to an expression and paste the function that represents all 30 of the actual values. After this activity, the newsletter initiates the two parallel process flows to create the newsletter content and the target mailing list. At activity 24, the parallel flows come together. The target list and the content must arrive before the newsletter can be sent. The Run Setup dialog box defines the length of real time, 1 month, that I want to simulate. The Resources dialog displays the workers available in each department and also their hourly rate. For production workers, $25 per hour. Simulating my model provides a report of the current resource utilizations, labor costs per department, and total labor cost. iGrafx Process for Six Sigma allows me to conduct rapid design of experiments. In the Rapid DOE dialog, I identify the experiment factors and responses. In this model, the factors are the resource counts per department. I'll test the current staffing level against adding one resource to each department. There are two responses I'm interested in: the total labor cost and the total number of newsletters sent. I'm running a 2-level, full factorial design producing 16 experiments. If necessary, I can also run experiments with center points. Replications are the number of times that each experiment will be run with a different random seed or sequence number. After clicking OK, the 64 factorial combinations are automatically generated by Minitab and shown here. Clicking Start executes all the simulations with a single command. Recall that there are 16 unique factor combinations with 4 simulation runs per experiment. The Run Experiment dialog gives a status of the number of simulations completed, and response values are added to the dialog for each set of factors simulated. When the Rapid DOE completes, a dialog displays the name of the Minitab worksheet where the results are stored. The simulation results are also available in the dialog where I do an initial analysis of good, sorting the factors by the responses that are key to the value I'm seeking. In this example, I sort the data by the newsletter transaction count. Based on the results, it appears that I might reach my goal of 70 newsletters per month by adding a single production worker. Next, I use Minitab to verify my staffing analysis. Minitab offers dozens of possible analyses. For example, a main effects plot defines the relationship between factors and responses in my model. For this set of data, Minitab generates 2 plot windows. As expected, adding workers to any department affects total cost. Note that the production count has the most significant main effect on transaction count. This confirms my earlier analysis. To test my conclusion, I'll run a final iGrafx simulation with 3 workers defined for production. The results are as expected. Over 70 newsletters are produced at the predicted cost. Thank you for watching this presentation. Minitab and SAS Jump are not sold by iGrafx.